All right, folks, we're going to be working on the second set of exercises here. So we're in chapter 2, doing the programming exercises, which start with exercise number 4, which is up on the screen here. And you'll notice here it says, write a program that declares a named constant to hold the number of quarts in a gallon. Also declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value. For example, 18, whatever that means. Compute and display the number of gallons and quarts needed for the job. Display explanatory text with values. For example, a job that needs 18 quarts requires 4 gallons plus 2 quarts. Okay, so the concept here is like you need a certain amount of paint to cover a wall, right? And these are calculations that painters have to do all the time. But you don't want to buy more paint than what you need. So for example, if you buy paint, it comes like in 5-gallon buckets, or it comes in 1-gallon cans, or in quart-size cans. If you do a calculation and you figure out that you need one gallon and a quart, why would you buy 2 gallons, right? It'd probably be cheaper to buy a quart and a gallon, right? And this basically is going to help us make that determination. That's kind of the point of this. So let's go ahead and jump over to Eclipse and let's get the program started first. So I'm going to close all my old code files here, right? Then up here in the Package Explorer, I'm going to collapse down my other projects. I'm going to leave them there. I'm not going to close them or anything, but I'm going to come up to the file, either the file menu or the first icon, and I'm going to create a new Java project, and this will be called Chapter 2 Exercises. Right? I'm going to go ahead and click Finish, and then inside that project, I'm going to right-click the source folder, click New, Class. Oops, I clicked Package, sorry. We're going to click right-click New, Class, and we will call this quarts to gallons, I think. What's the name? And I'm just going to verify that because I already forgot. All right, quarts to gallons.java. Okay, so let's go back over to Eclipse. We're going to accept that name, and we're going to add a public static void main. All right, I'm going to get my file folders out of the way here. And then as I get ready to do this, I have to start thinking about the information, first of all, that they just kind of gave us, right? So you think about the information that they put in there, and they were really specific. They were like, you want to create a constant, you know, they said exactly what we should do. So let's do the stuff that they said exactly what we should do, right? Because it's going to be required. So back over at the book, it says, declare a named constant to hold the number of quarts in a gallon, which is 4. All right. So back over in Eclipse, and I'm doing this inside the main method now. I'm going to declare a constant. Now, if I do a constant, I have to start with the keyword final, right? How many quarts are in a gallon? Well, there's 4. That sounds like a counting number to me, which is an integer, right? So integers are counting numbers. So the data type is int, and then I'm going to give it a name. When I do a constant, I use all caps, underscores to separate the logical words. Oops, and you see I'm like already breaking the convention here. And I'm going to say quarts in gallon. How many are there? 4. So there's 4 quarts in a gallon. Okay, why do we make this a constant? Well, that's a given, right? This is, I mean, I'm not going to wake up tomorrow and there's going to be 5 quarts in a gallon. There's 4 quarts in a gallon today, and there'll be 4 quarts in a gallon tomorrow. So this makes sense for it to be a constant. It's not going to change. Okay, so that's kind of the why. So there's your first example of creating a constant. Also declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value, for example, 18. So in other words, when we do the second part, which is part 5, we're going to ask the user for how many quarts we need. That's kind of the point. For now, we're just going to assume that number is 18. And we're going to write this in a couple of different ways, right? So how many, let's see, quarts needed for a painting job? All right, so we're going to come up with these variable names here. So quarts needed, well, that sounds to me like an integer because it's going to be a counting number. We can't buy like, 2.5 quarts. So you buy 1 quart or 2 quarts, if you see what I mean. So it's going to be an integer, and we're going to call this quarts needed. Notice the capital N. I'm not going to assign a value here yet, although actually I am saying that I am. And now I'm kind of waffling here a little bit on what I'm going to name this. So I'm going to change my mind here. I'm actually going to call this quarts total. How many quarts total do I need? That's my mindset. We're told to start with 18. So I'm just going to hard code that. When I write the interactive version of the program, the user is going to enter this number for me. Okay. So here's kind of my thinking on this, why I switch from quarts needed. Because if I decide that I need 18 quarts, there's 4 quarts in a gallon. 4 doesn't divide into 18 evenly. So even though I need 18 quarts total, I will need some gallons, like 4 gallons, but then I also need 2 quarts. So I still need quarts needed. So I'm going to create 2 more variables here to kind of store stuff. So the first one is I'm going to create an integer called gallons needed, right? I don't know what that's going to be yet. It depends. That's going to be the result of some math. I'm not going to preset it. But as I just demonstrated, if it doesn't divide in equally, then I'm also going to need to get some individual quarts. So I'm going to say quarts needed. So the ones that say needed are the things I actually need to buy. The one that says total is how much I need total, right? So if I was to do this calculation now, because there's a little bit of math that needs to happen, and I kind of already alluded to it, how many quarts are in a gallon? There's 4. I have a need for 18 quarts, so I got to do a little bit of math to figure out how many gallons I need. So the variable that I named gallons needed, that's going to be something I can calculate. So I can say that gallons needed equals the quarts that we need, quarts total divided by the number of quarts in gallon. This is kind of interesting because as I'm working this, I'm kind of half expecting my IntelliSense to kick in and help me type. Did you guys notice it wasn't like helping me at all? I think that's kind of weird. Sometimes it does that, sometimes it doesn't. It could be because of all the memory I'm kind of chewing up on the system. All right, so I'll take that quarts total divided by 4, basically. That will tell me with 18, that should give me an answer of 4. It's going to give me 4 gallons that I need. But now I'm going to have 2 quarts left over. There's going to be a remainder. And then how am I going to figure out that remainder? All right, so this is where it gets kind of weird. So now I'm going to type the second statement. I'm going to say quarts needed equals quarts total. Once again, same value. This time, well, I want to divide, but I want to get the remainder. Remember, we have this like special math operator called modulus. So we're going to use the modulus operator here. And once again, divide by quarts. Where's my IntelliSense? See, that's what happens when you start leaning on it and then it doesn't work, right? So we're going to divide by the same number, and then this value will end up being 2. So we need to get 4 gallons and 2 quarts. And then we also need to kind of put that back on the screen. So we need some sort of a result to go back to the user. And so I'm going to do a system out print line. So here it goes. System dot out dot print line. And we're just going to say something like this. And we can mimic the message that was in the assignment. So it was like a job that needs, and now we want to display the original number of quarts total. So we'll just say that. So I'm not going to like hard code 18. I'm going to hard code the variable name, which is quarts total, right? And then, so that number is going to appear here as text, and then I have to concatenate it back to more text. I'm going to put an extra space here. So notice I'm putting a space here because otherwise the number is going to touch the word, and then the number will appear, and then I'm concatenating a space here before I begin more words. Otherwise it touches on both sides, right? And so I'm going to say a job that needs 18 quarts, comma, requires, you notice I'm running out of space over here. I'm going to put an extra space here. I'm going to press enter. Oops, I'm going to press enter, put in a plus sign, my concatenation symbol, and then I'm going to continue my string here. But now I'm going to throw in a variable, and actually it's not going to be a string quite yet. So we're going to say gallons needed concatenated to gallons plus, I know this doesn't make sense as you're typing it out, but I have worked out the logic before because I'm reading it from a solution. Quarts needed plus quarts. And this is, this is kind of weird because you have to accommodate for the fact that wherever I have variable names with concatenation symbols on both sides, we're throwing in a number as text, and then we need that space, right, so that things don't touch, right? Then you have to remember that whenever you're concatenating like this, you have to insert those spaces, otherwise it starts looking kind of ugly. All right. So now we need a semicolon here at the end to terminate the statement. So it's a system out print line that has variable names in the middle of it to output, concatenated with statements to hopefully make it make sense. Let's run this and see if it actually works. So first I'm going to hit save, then I'm going to hit run. Okay, it says a job that needs 18 quarts, comma, requires 4 gallons plus 2 quarts. Okay, is that how the book listed it? Let's see. A job that needs 18 quarts requires 4 gallons plus 2 quarts. Okay, so we got the output is right. I think our math is okay. Now, here's where it gets kind of interesting because exercise 5 is really a revamp of what we just did. And all that we're going to add to it, and if you read it, says, convert the quarts to gallon program to an interactive application, meaning we're going to prompt the user for the quarts total, right? Instead of assigning a value to the number of quarts, accept the value from the user's input, and then we're going to save the revised program as quarts to gallon interactive. All right. So if you want to do that, you want to save it as a different program, that's absolutely fine. So what you could do is you could come in here, right click, new class file, right? And then say quarts to gallons interactive. And I'm going to say that, if you want to do a separate file like this, that's on you. I'm okay if you turn in exercises 4 and 5 together. And so I'll do that. That's what I'll do next time. But here I'm going to make a separate one. And you know what? And if you haven't realized this yet, it's a copy of the same program. So I have to go back to the previous file. And I'm just going to copy all of this stuff inside here. But only the stuff inside the curly brackets inside this main method. So I'm going to right click and copy. And I'm going to come over here and I'm going to paste it all in. There's my paste. All right, but we have something extra we need to do, right? And the thing that's extra that we need to do is we need to get input from the user. So here in the main method, I've already declared my variables and my constants, and a good place to do the prompting is somewhere near the top. And so like if you guys want to do comparison to a recipe, by the way, this would be like our ingredients. And now we need to get input from the user, which starts here. So we'll do this a couple of different ways. What the book would have you do is this, and I'm just going to type this in, is they'd have you go up to the top of your document and add an import statement like this. It would say import java.util.scanner with a capital S, semicolon. That gives us the scanner library for getting information from the user, all right? And then you can come down here and start typing scanner, blah, 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 all right? But here's kind of become my habit. So when I work with an IDE that has IntelliSense, I tend to do this more. I'm just telling you guys so you can kind of get in this habit, is I would just come down here and start typing scanner. It underlines red immediately, right? And I can fix this in a couple of different ways. First, I can hover, right? And notice as I hover, it says 9 quick fixes available, but the top one is the one we want. We want that import statement. We did this before. I don't know if you guys remember, but you can just hover here, click that, and it adds it. Fantastic. Great trick, right? Okay, I'm going to Control Z that. All right. Here's another way. If you type this in and it underlines and your cursor is still right here, if you do Control space, you guys catch that? Meaning you're taking the first quick fix, which is always the import statement, it adds the library automatically. Isn't that pretty slick, right? And so this is why I do it this way. This is the fastest way. And so that's the way I do it typically. All right. So, all right, we're setting up the scanner. We need to give it a name. You can call it whatever you want. I'm just going to call it input. Sounds pretty logical since they're going to give us input. And then we have to do what we call instantiate the scanner and make a copy of it so we can use it in memory. We do that by using the new keyword, and then we say scanner again. And then inside of parentheses, we say system, not dot out, but dot in. Now we're getting input instead of output, right? At the end of the line, we still need a semicolon. All right, so that's getting the scanner so that we can receive input from the keyboard. Now we're going to put a prompt up on the screen. And what I'll do is just do a system dot out, careful here, print, not print ln, just print. And then we're going to put a message on the screen to prompt the user, which will say, please enter the number of quarts of paint needed. And then because I'm prompting, I do something like that, right? Pointer, I'll leave a little extra space there. And then that message is on the screen. And when it gets on the screen, the cursor will be flashing at the end of the line because it didn't move down. Print line moves the cursor down. Print leaves it in place. Prints the text, leaves it in place. All right, so the prompt is on the screen. Now we're waiting for the user to type it in. So the user has their prompt, they're typing something at the screen. Now we must capture it. Now, in the previous program, we preset the value of quarts total to 18, but now we want the user to enter it, so I am deleting the value. So make sure you do that. Then on line 14 here, I'm now going to say quarts total, and I'm going to set that equal to my input, which is the scanner, and then depending on the kind of data I'm expecting to receive, I'm expecting an integer entry here, right? I'm going to type next int, which will grab the integer and then store it in our variable called quarts total, which holds integers. So it's a prompt capture of the information. We're expecting an integer. It stores it in quarts total. Once again, look at like the layout here. Whatever's on the right side, so we get a prompt that captures information from the keyboard. It stores it in the item on the left side. kind of an interesting correlation. Now, everything else in the program is just going to work. Now, instead of it being hard-coded, we're asking for the info. That's the only difference. Now, there's another thing that you will get. So like a lot of people will notice here that we get this little yellow warning. It's a warning. It won't stop the program from running, but it is saying a message, and it says resource leak. Input is never closed. Okay, so this is kind of an etiquette thing. It is not really required. Our author in our book like never does this, but I try to always do it, right? So since I have an input that I used, I want to release it back to the system, so I do a close command. So I say input.close with parentheses and a semicolon, and that means that the keyboard entry from the system is now released, so a different program can enter something if they want. Now, if you don't put this in, once the program ends, it goes back to the system anyhow, right? And console programs, by the way, end instantaneously. This is why the author doesn't do it. I like to put it in because it's good habit, right? So if I'm opening an input, I want to close the input to not have problems down the road, especially if the program keeps running. Okay, so that's just a good habit. So what you're seeing on the screen now then is basically the entire completed program without the scanner at the top. Let's run it, see what happens. All right, so this will be our first program that prompts the user. So we hit the run button, asking us to save. So we'll go ahead and save, and it says, please enter, oops, misspelling here, number of quarts of paint needed. So I'm going to type in the number I know already, which is 18. And you got to click into the window here, and I forgot to do that. So I'm typing, make sure my num lock is turned on too. So there's 18. I press enter, and it gives me the same answer. Now let's try a different number in there. So what if I run it and I say 20 quarts? Well, 5 gallons even and no quarts, right? Because 4 goes into 25 times, right? If I run it again and then say, I don't know, like an odd number, like 27. Well, it requires 6 gallons plus 3 quarts. Is it working correctly? Yeah, it totally is. So this would be exercise 5, folks. This is quarts to gallon interactive. I'm assuming you guys are all okay. Right. Let's see if we can get a start on the next one so we don't have as much work to do next time. Also kind of get you guys kind of moving in the right direction here. We're going to write a program that declares named constants to represent the number of inches, feet, and yards in a mile. Interesting, okay. Also declare a variable to represent a number of miles and assign a value to it. So kind of like we did before, we hard-coded the 18. Compute and display with explanatory text the value in inches, feet, and yards, and save the program as mile conversions, and then we'll do an interactive version for number 7. All right, so I'm here on my other screen. I'm trying to get rid of these extra file windows here, so I apologize. We're going to work on the next exercise here. And just getting my cheat sheets up on the window here. And so let's begin by making a new program. So right inside chapter 2 exercises, we're going to right click. We're going to do new and say class. And this will be mile versions. I'm not sure if that's exactly how they titled it, but that's what I'm titling mine. Public static void main added. We're going to get rid of their default comments here. And I'm going to begin with the stuff they asked me to do. So they wanted me to have named constants for the number of feet, the number of inches, and the number of yards in a mile. Okay, so I'm going to start with the number of feet. And if you're wondering why, it's because I actually know that one off the top of my head. So I'm going to say final. It's going to be an integer. And we're going to call it feet in mile. Okay, so how many feet are there in a mile? Well, it's 5,280. I don't know why I remember that, but I do. Maybe because they drilled it in me as a child, right? Makes no sense, right? Why that many feet in a mile? It's just somebody just decided. All right. Now we need to have the number of inches in a mile, but I'm going to have you say that I don't need to go somewhere else to figure this out. I do know that there's 12 inches in a foot, and I know how many feet there are in a mile. So it's an extrapolation of the first constant. So I can say final int, I can say inches underscore in mile. And all I have to do is take the feet in mile and multiply it by 12, right? Because there's 12 inches in a foot, right? So if I multiply 5280 by 12, that will tell me the inches, correct? Yeah, it is correct, by the way. All right. Same thing with yards in a mile, same kind of thing. So I'm just say final, I'm going to say int, and then I'm going to call it yards in mile. And this time we'll do the same basic thing, but instead of multiplying, we will be dividing the feet in miles by 3, right? Because there's 3 feet in a yard. So if I take 5280 and divide it by 3, that will give me the number of yards and we'll store it. See, so I don't need to know those values. I just need to know how to get to them. But once this statement executes in code, whatever that calculation is, will store here and stay there. Doesn't matter that I don't know it off the top of my head. Yes, I could go to a calculator or a spreadsheet and calculate the value and hard code it. What I'm showing you here is that you can wisely do it just with programming code. You don't need to calculate it externally. We'll let the software do the calculations. All right. Now, the other thing that they want me to do, right, and this is something we're going to hard code, just like we did the 18 quarts in the previous one, is we're going to hard code, at least for right now, the number of miles we're going to be evaluating. And I think the example was 36, right? And so out of that, we have to determine 3 different things. First, we have to determine the number of yards that we calculated, right? I'm not presetting it. That's going to be calculated. We're also going to calculate the number of feet, and we're also going to calculate the number of inches. And you can kind of see the pattern as I'm doing it, right? It makes sense. Now, to do the calculations, those are, I'm going to do these kind of quickly so that we can kind of get it done, by the way. So I'm copy pasting these, by the way. So here's the first one. If we want to figure out the number of feet, we take the number of miles, the one that's going to be eventually input, multiply it by feet and mile, and we'll store it. Then if we want to get the number of yards, there it is. And if we want to get the number of inches, very, very similarly, use the same approach, basically. There's the calculation. Right. Now, we want to test that this works. So this 36 is a test value before we ask the user for input. So now we're just going to write a series of system out print lines. So here comes the first one. So the number of miles is equal to, and then you'll see, we're going to continue this on the next line. And I just for time efficiency here, folks, and I know you guys can go back to the video and watch this later, but then we're going to take the calculations that we figured out above, and we're just going to output that. So in other words, if I type in 36, this is going to read 36 miles is equal to whatever feet, whatever yards, and whatever inches. And you know what? Let's run it and try it. So I'm going to hit run. Asking to save, I will say okay. And we'll say 36 miles is equal to 190,080 feet, 63,360 yards, and whatever that is, 2,280,960 inches, right? Now I could go to a calculator and validate all of these calculations, but I do know these to be correct, right? What we would do next is we would make an interactive version of this. So I'm going to do it really quickly. I'm making a new class file. We're going to call it mile version interactive. We'll do public static void main. We're going to go back to the previous program and copy all our logic. Why reinvent the wheel, right? Just copy all of that. And we will just paste it in. The thing that will change here, though, is we're not going to have this preset, right? So we're going to delete it. And then we're going to set up our scanner. So I'll show you my way again. So I type scanner, it underlines red, hold down the control key and then the space bar. It adds the library automatically. I love that trick. It's just very slick. We will say input, and then we'll prompt. No, actually, we have to instantiate the scanner. So we have to do scanner, and then say system.in and a semicolon. Now we prompt. So here's where we do our system.out.print, and our prompt will say, oh gosh, I have to find what did I say last time? Not that. You got to pull the right file into your solution here. I said, please enter the number of miles it takes to get to work. That's what I said. Please enter the number of miles it takes to get to work. So, closer, double quotes there. Then on the next line, after the semicolon, I'm going to populate that variable number of miles with the input from the keyboard converted to an integer. So we say next int, like that. That also absorbs the pressing of the enter key, by the way. All the calculations stay the same. The only difference here is we're prompting the user and grabbing the value from the keyboard. All right, so let's run this and make sure it works. It will prompt to save, which we will do. And we're going to use the number we already know. So we're going to type in 36, press enter, and you can see the same values. We'll run it again. That's pretty ironic because I use 36 here, and that's about how far I have to drive when I go from home to the Racine campus. It's actually it's 38 miles. And because I can't take interstate the whole way, it takes me almost an hour to get there, unfortunately. But I do know some people that drive a lot further than I do to go to work. So I have one friend who lives on the south side of Chicago and drives up to Kenosha. And I don't know how many miles that is, but it's got to be like 80 miles. So I'm just going to put in 80. So 80 miles is equal to 422,400 feet, 140,800 yards, and 5,068,800 inches. All right. Goofy, but proof of concept that it works. So we finished the first two sets of exercises here, folks. So just kind of going back to the course shell really quick. We basically finished 4 and 5 and 6 and 7. For those of you that are trying to get this in on time, which it should be all of you, the remainder of the exercise solutions will appear in a video that I will activate right when this Zoom session ends. I will turn on the homework videos, which will appear right here. And you can use that to watch the rest. We can talk about those solutions next week if you need. But I'm kind of thinking in my head, if you have the videos there and you're able to get this stuff to work so far, you should be okay. It's just a matter of following me. But if you do get stuck, come to the office hours before class starts next week. I'm happy to help you, or set a one-on-one appointment with you and we can figure out what's going wrong. All right, folks, this video will end here. And there it